All right, so we have one more example to do with our one sample test for the mean. So we've gone through and we've done a t-test, a z-test, and we've talked about the differences between them. So let's go through our last example and determine what test to use and sort of go through our hypothesis steps. So example 3 says the statistics professor claims that the average score in the final exam was 91. A group of students believes that the average grade was lower than that. They wish to perform the professor's claim at the alpha equals 0.05 level of significance. All right, so we know the significance level. You can see with this question that each piece is sort of the hypothesis test. They've broken it into, parts A, B, C, D, and E. So we'll still go through them, but they're sort of prompting us what they want to see here. So A says write our null and alternative. So my alternative, it's talking about the average score. So we're going to use a mean here. And the professor said, claims it was 91. And the students believe it was lower than that, so less than 91. So since it's less than, it's going to be a right-tailed test. Okay. And then it goes on to say that a random sample of statistics students had the final exam scores shown below. Assuming that the test scores are normally distributed, use the sample to find the test statistic. Okay. So instead of just telling us what's the sample mean, what's, the sample size, what's the sample standard deviation, or even the population standard deviation, we just have data. So since we just have data, we're going to use our t distribution, or a t-test. Since I just am going to end up with a sample mean and a sample standard deviation. So in order to do this, we've entered data before. So anytime we enter data, we are going to go into our stat button. And we're going to go into edit, and we're going to enter the data into L1. So you may have some data already entered. I'm just going to clear this out quick, maybe from something we did in the previous chapters. I'm going to clear out L1. And now I'm going to enter this data that I have. And remember, it doesn't matter the order. So you could go by rows, columns, totally up to you. But you just want to make sure you enter all of this into your calculator. So I'm just going by rows here. 6, 8, 94, 62, 54, 72, 78, 93, 96, 76, and my last one, which would be 96. Okay. So I've entered everything in. Now I'm ready to do my t-test, and we're just going to use the calculator for this, not really any formulas. So I'm going to go back to my stat button. I'm going to go over to tests, and I'm going to go down to the t-test. Hit enter. And I don't have the statistics in this case. I have the data. So I'm going to arrow over and hit enter for the data. I'm going to then type in all the information that I do have, So 91 I have for... they're saying, for that final exam. Now, my list, my data that I entered, it is into L1. Frequency, we're just going to leave at 1. It looks like less than I do still have for this one. So I'll go ahead and hit calculate. And so if I want to find the test statistic around to 2 decimal places, that's going to be the t value that I see there. So it looks like t, is negative 3.52. Okay, so again, it's a right-tailed test. So negative 3.52 would yield, a p-value. So let's see, p-value, is the line below. So 0.0016. 0016, that's the p-value. Now it says, which is the correct result? Are we going to reject or we do not reject? So if I recall, this is what we sort of did before. So 0.0016, this is my p-value. We want to compare this to alpha. So since alpha is larger, we are going to reject, Reject the null. So we're going to reject the null hypothesis. And since we reject it, there should be enough evidence to suggest, that the average final exam score was less than 91. So the claim that the professor is making that the average score for the final exam was 91, that doesn't seem to be true. The sample that they collected shows otherwise, And you can sort of see from the data, it's sort of mixed, but there are quite a few low numbers. There are still some 90s, but it's probably, more along the lines, if you look the mean, but with that sample is 77. So definitely probably love a T. Just have the data. So we're going to enter the data into the calculator and just tell the calculator we have the data so it can figure out the mean, the standard deviation, right? As you can see here, it has the mean and the standard deviation. And we can still find the test statistic p-value and make our conclusion.